Think about the last time you were waiting for something important. A message, a call, an answer that would change everything. And every second felt eternal, every minute torture. Time dragged on. But here's the strange part, the truly unsettling part. Time wasn't actually moving more slowly. It was you, your perception, because time, it turns out, is not what you think it is, and what I'm about to tell you will make you question every second you've lived up to now. There is a limit in the universe, an absolute limit. And it's not just a big number someone decided to write in a physics book. It is the very structure of reality itself. It is the fabric of space and time telling you, this far, no further. And the craziest part is that this limit, this boundary between the possible and the impossible, you cross it every day without realizing it. Every time you turn on a light, every time you look at your phone, every time you feel the warmth of the sun on your face. The speed of light, 300,000 kilometers per second. Sounds fast, right? But it's not just speed. It's something else. It's the speed limit of the universe. Yes, but not because someone decided it should be. It's the limit because it cannot be otherwise. And understanding why, really understanding why, means dismantling everything you think you know about space, time, and causality itself. I'm going to take you on a journey. A journey that began centuries ago with a man watching lamps swing inside a cathedral and ends with one of the most disturbing revelations of modern physics. But before we get there, let me ask you something. Have you ever felt that the universe has hidden rules? Rules they never taught you in school. Rules that make everything seem strange once you discover them. Galileo Galilei was in a cathedral when he saw it, a hanging lamp swinging back and forth. And he realized something no one else had noticed. It didn't matter how wide the swing was, the time it took was always the same. The pendulum had a rhythm, a constant rhythm, and that was strange because it meant that time and motion were connected in a way no one had imagined before. Galileo began to think that maybe the universe followed mathematical rules, precise rules, rules you could uncover if you watched closely enough. But it was Isaac Newton who truly changed everything. Newton connected phenomena that seemed to have nothing to do with one another. An apple falling from a tree, the moon orbiting the earth, the tides rising and falling, all of them obeyed the same law. Universal gravitation. A single equation explained everything. And that was powerful. It was beautiful. Because it showed that the universe was not chaotic. There was order, a deep order. And if you could find the right law, you could predict the future. You could understand things that seemed impossible to understand. Then came Ole Rømer, a Danish astronomer obsessed with the moons of Jupiter. He observed them night after night. And he noticed something strange. The moons didn't appear when they were supposed to. There was a delay. Sometimes they arrived late, sometimes early. And Rømer realized something incredible. The delay depended on how far Earth was from Jupiter. When we were farther away, the moons arrived late. When we were closer, they arrived early. And that could mean only one thing. Light didn't travel instantaneously. It had a speed. It took time. And Rømer calculated that speed, not perfectly, but close enough. And that was the first hint that light was special. But no one understood why. Why did light have that specific speed? Why not faster? Why not slower? For centuries, it was just a curious fact, a number you measured and wrote down. But then Einstein arrived, and Einstein changed everything again. Only this time, what changed wasn't just physics, it was reality itself. Einstein was thinking about light, thinking about how it moved, and he realized something that contradicted all common sense. If you're standing still and you measure the speed of light, you get 300,000 kilometers per second, obviously. But now imagine you're in a rocket, moving almost at the speed of light, and you measure light again. What do you expect? You'd expect the light to seem slower, right? Because you're almost catching up to it, like when you run after a car. The car seems slower because you're moving too. But no, with light, it doesn't work that way. You measure the light, and you still get 300,000 kilometers per second, exactly the same. That makes no sense. It's impossible, unless space and time are not what you thought they were, unless they are adjusting, changing, so that the speed of light is always the same no matter how you move. And that is exactly what happens. Time slows down, not a little, it really slows down. If you travel fast enough, your clock starts ticking more slowly compared to someone who is standing still. It's not that the clock is broken, it's that time itself is moving more slowly for you. And space contracts. Distances shrink. Not because you're imagining it, because space itself is changing to remain consistent with that constant speed of light. This is not philosophy, it's not metaphor, it's measurable. We have measured it, we put atomic clocks on airplanes, we fly them around, and when they come back, they are behind compared to the clocks that stayed on the ground. Fractions of a second, yes, but behind. Time really was slower for them, and satellites in orbit have to constantly adjust their clocks because time runs differently up there. If we didn't make those adjustments, GPS wouldn't work. You'd be off by kilometers. So why? Why is the universe built in such a strange way? This is where everything becomes truly unsettling. Because it turns out the speed of light is not just a speed limit, it's a causal limit. It's the limit of how fast cause and effect can propagate, how fast information can travel. And without that limit, without that absolute boundary, the universe would collapse into a chaos of impossible paradoxes. Think of it this way. Imagine you're here, and something happens over there, very far away, say a light year away. Something explodes, a star. When does it affect you? Not immediately. The light from that explosion has to travel to you, and that takes a year. During that year, you and that explosion are disconnected. There is no way for it to affect you. It is outside your now. It is in your future. Only when the light arrives, when the information arrives, does that explosion enter your present. It becomes part of your reality. And here's the crazy part. Nothing can go faster than that. Nothing can bypass that limit. Because if it could, if you could know about the explosion before the light arrived, you would be receiving information from the future. And depending on how you move, on your frame of reference, that could mean receiving information from the past. You could send a message to your yesterday self. You could tell yourself not to do something you've already done. And that's a paradox that would destroy causality itself. The universe does not allow that. It cannot allow it. Because if cause could come after effect, if the future could change the past, then nothing would make sense. There would be no sequence, no logic, just chaos. That's why the speed of light is absolute. It's not a suggestion. It's an iron law that keeps the entire fabric of reality intact. That's why nothing with mass can reach the speed of light. It's not because we don't have powerful enough engines. It's because the faster you accelerate something, the more energy you need. And as you approach the speed of light, the required energy grows without limit. It becomes infinite. You would need all the energy in the universe to accelerate a single electron to the speed of light. It's impossible. Not technically impossible, fundamentally impossible. Only massless things can move at that speed. Photons, gravitational waves, things with no inertia, things that cannot move at any other speed. For them, the speed of light is not a limit. It's the only speed, the only one that exists. And from their perspective, from the perspective of a photon, time does not exist. It does not pass. A photon emitted at the Big Bang and a photon emitted now experience exactly the same time. 0, because at the speed of light, time completely stops. Now think about what this means for space and time. They are not separate things. They are not empty containers where things happen. They are part of the same structure, space-time, a single fabric that stretches, bends, and curves. And the speed of light is the constant that keeps that fabric coherent. It is the thread that weaves everything together. When you accelerate, space-time adjusts. Time slows down for you. Space contracts in front of you, not because you're doing something special, but because the universe is keeping the speed of light constant. That is its priority. That is its unbreakable rule. And everything else, time, space, mass, energy, adapts to satisfy that rule. And here's something that fascinates me. At the quantum level, particles don't take just one path. They take all possible paths simultaneously. An electron going from here to there doesn't travel in a straight line. It travels along every imaginable route, straight lines, curves, zigzags, loops, all at once. And somehow, when you add up all those possibilities, all those ghost paths, you get the path you actually observe, the path that manifests in our reality. This isn't speculation, it's pure mathematics, verified again and again in laboratories. Particles really do explore multiple paths. And what determines which paths matter most, which paths contribute most to the final result, is the action. A quantity involving energy and time. And guess what? The speed of light is there too. It's always there, in every equation, in every calculation. It's the fundamental constant that appears again and again because it is part of the basic structure of the universe. If you made it to the end of this video, comment "I made it," and I'll personally reply. And if it resonated with you, subscribe to be part of this journey. And hit like if you enjoyed it,